Hello viewers, welcome to my YouTube channel. This is Sarayu. Asymptotic notation, it is the important concept of DA subject first unit. They will ask its types and or in case in some cases they will ask a single type. Asymptotic notation, it is a notation explains about the performance of an algorithm, how it performing, good or bad, like that. And asking one more questions like time complexity or formulas, examples, space complexity of an algorithm, and a representation. Like this representation, they will ask as a one mark. We use various types of notations like big O notation, small o notation, omega notation, theta notation. These are the four types we use for asymptotic notation. It is the process of taking input with size n becomes very large is known as asymptotic notation. First type is a big O notation. It is used with big O symbol. It is a representation of upper bound of an algorithm. Like this upper side of x coordinate, this x coordinate, y coordinate, x axis, y axis. This is a representation of origin. F of x and g of x will be upper state or upper bound in a graph representation. Therefore, f of x and g of x will be non-negative, is known as positive functions in case of big O notation. Mostly frequently used this type of notation, and worst case time complexity will be in big O notation. This is the example of big O notation. F of n equals to 2n plus 2, g of n equals to n square. First we need to write the given that information and substitute n place equals to 0. Then f of 0 equals to 2 of 0 plus 2 into 0 will be the value equals to 0 plus adding 2 equals to f of 0 equals to 2. G of 0 equals to n square. Here n is 0, so 0 square is 0. F of 0 is 2. G of 0 is 0. F of n is greater than g of n. 2 is greater than 0. Substitute 1. F of 1 equals to replace a value 1 with n. N place we substitute with 1 as it is for g of n. Here f of n is greater than 1. Substitute n equals to 2. Continue the process for up to n equals to 3. In case of n equals to 3, f of n is less than g of n. This is the point. So sum of elements in an array, we use this concept. Algorithm sum. Sum S is the size, n is the number of elements. Size, S is the array name. Open bracket, writing the main function, total equals to 0. For loop, I 0 to n, total equals to total plus S of I, depends on I value. Closing, S of P is the space complexity is equals to C plus SP. Here we are adding the one values like 3 plus n. This is the order of n. I is the initializing value like 1 unit, 2 unit, like that. N is the size, S is the array name.